So we are talking about fronts here. So what really a front is, basically it's a boundary between two air masses. So I can write a definition stating that it's a boundary between two different air masses. We have talked about fronts in I think one or two videos before. So like a cold air mass approaching a warm air mass, or a warm air mass approaching a cold air mass. So like this is warm air mass and this is maybe cold. So when cold is approaching a warm air mass, or if this is cold and this is warm, so then warm is approaching a cold air mass. So this is how the fronts work. So they are the boundary. So basically I would say if in yellow I would say there's a boundary when they are closer to each other, when they're almost there. So it's a boundary between the two air masses. Now you have to understand that air masses are at different locations, so they have different values to it. For example, any air mass that would be over water would have a lot of moisture. If any air mass is over land, will not have as much moisture. If any air mass is near the poles, then it will be cold, the temperature would be lower. Air mass which would be near to the equator or tropical area, it would be warmer. So this is how air masses are. So on the basis of the same, there are different air masses that are there. So there is a continental Arctic, maritime polar, continental polar, maritime tropical, continental tropical, maritime tropical. So we need to understand the keywords, and then we'll be able to know that if an air mass is warm, dry, cold, hot, whatever. Okay, so if it is a maritime, that is basically for water, so it will have a lot of moisture, so it will be moist, right, this air mass. If it is, for example, polar region, then it will be of course cold. If the air mass is over continental, right, it will be dry, because now this is land. When we talk about tropical, it will be warm, because now it's near the equator area. Okay, and when we talk about so now we could mix and match these. So if you see in this picture, there are a lot of air masses that they're talking about. So if there is polar, okay, let me take a yellow color. Yeah, so this is a maritime polar. So maritime is moist, polar is cool, so it will be cool and moist. Then we talk about continental polar. Of course, polar is cold, so dry and continental. Then there's continental Arctic, right? Then there's maritime polar, then there's maritime tropical, continental tropical, maritime tropical. So depending on where the air mass is, and is it land, is it water, is it polar region, is it equator, whatever it is, depending on that we could define or describe that particular air mass. Will it be warm, will it be cold, will it be dry, will it be moist or not? So this is how you would say it. So let's talk about warm front first. So basically in the warm front, the warmer air is overtaking the cold air. So over here we have the warm air basically, coming towards the cold air. Okay, so this is, if this is my warm air mass. Okay, now this is I'll make it with yellow so it's more visible. So this is basically approaching, it's coming here in this direction and overriding the cold air. Why is it overriding? Because obviously cold air is denser, warm air is lighter as compared to the cold air. So it glides over the cold air like this. Obviously it can't move the cold air. So because of this, because of the difference in temperature, there is obviously a decrease in temperature now, and there is a difference in temperature between the warm and the cold air. So there are a lot of clouds formed. Okay, so there are a lot of stratiform clouds formed here. So whatever I'm mentioning, just keep remembering that, okay, because that's important. So there are a lot of stratiform clouds that are formed because of the difference in temperature. And also it's not a very steep slope, so the slope is 1:150. So you could write, so in the first point we would say that warm front is basically warm air mass approaching the cold air mass. Okay, this is first point. The second point is that stratiform clouds are formed. The third point is the slope, which is 1:150. Okay, so I'll tell you what that really means, because warm air is moving slowly, it's going up, and the speed is also approximately, you could say 10 to 15 knots. In this, it is slow because it's very difficult for the warm air to push the cold air, because cold air is denser. Hence, that is why the slope is also not that steep. It is 1:150. That means for every, what does this really mean is, for every 150 nautical miles, the front covers horizontally. Okay, it moves, the air rise up by 1 nautical mile. The air rise up by 1 nautical mile. So basically अगर वो 150 nautical miles horizontally move कर रहा है, this portion of air is moving like this, तो इस पूरे 150 horizontal में it will just go up by 1 nautical mile. So it will go up by 1 nautical mile. So this is one of the properties. This is the slope that we are talking about here, which is quite shallow. So this could be called as a shallow slope. Okay. So now what really a warm front is, it's the boundary between the cold and the warm air mass. So if I erase all of these items here that I've made, now what really a front is, so if this is my warm air, this is my warm air rising over cold air mass. So this boundary between the warm air and the cold air is the warm front. This is what a front is. It's a boundary between this. Now in this front we have to, okay, so just take a screenshot of this because I'm going to delete all of this and I'm going to explain something that's really important. Also what will be asked in the questions, right? Okay. So now there is something called behind the front, at the front and ahead, and how do we choose that? I'll explain you. So if this is the front taking place, okay, so in this particular case, this front air is moving. So this is at, right? This is when the front is actually taking place. It's when it is there happening. Now the part which is after the front, basically this portion, this is known as ahead, or it also is known as before. Why before? Because the front is happening before it. So it will obviously keep moving in this direction. Every 150 nautical miles it is going horizontally, it is rising up by 1 nautical mile. So ये before area, before the front has arrived to this location. This is also known as behind, because one, it is behind the front that is happening, plus it is also known as after. Because why after? Because now the front has moved from this location and come to this at location. So this is after the front has moved ahead, and this is before the front has arrived. This is behind of the front, this is ahead of the front. So don't get confused with these terms. They are very important. And now we are going to make a table based on it. So we are going to talk about the properties that are there. We are going to talk about before, or you could say after, like I just explained. Then there is something at the front, and then there is something ahead, or you could say before. Okay, so these pointers are really important. These terms that I'm using is very important, that what is at, what is ahead, and all of that. Okay, properties. Okay, now we have to talk about what are the properties. For that we need to know like the temperature. For example, I'll zoom it a little bit. Temperature. So what is the temperature behind? Since the air that was coming from behind towards the cold air was warm, so the temperature before would obviously be warm, right? And it is mixing with the cold air at the front, so it is going to rise. The temperature is going to get hotter, and of course since the cold air was ahead, so this would have been colder. So this is how the temperature is. Now when we talk about pressure, the pressure is now why is the pressure? Okay, so pressure is going to be high because it's moving from high to low. It is moving in the lower direction. So this is rising pressure, basically high. Okay, here the pressure is steady where it's mixing over with the cold air. So air is rising is why the high pressure is becoming lower. So here it becomes, basically it falls, becomes lower. Okay, because now the air is rising up, that is why the pressure is falling. Then we talk about the winds. Okay, winds, since now in the before area, wind is going in the veering direction. If you have seen my previous video, you would know what veering is. So when it is veering, it's going in the ahead direction. Here it is variable, okay, and here it is backing. Why backing? Because cold air is underneath, right? And when it's backing, it's getting a lot of friction. Then we talk about the clouds. they are scattered here. This is something that you would know. We have already talked about the sorry, I'm written the wrong spelling. So we have already talked about the stratiform clouds that are formed, that actually results in the formation of fog. It's also because of the temperature difference. And after, like, or maybe you would say ahead or before the front, here you get a lot of nimbus stratus clouds, you get a lot of altostratus clouds, you get a CS clouds, CI clouds, cirrus and all. So all these clouds. So nimbus stratus obviously means that there's going to be heavy rain. And why is that? Because the warm air is mixing with the cold. Of course, there's going to be rain. The temperature is going to get different. It's going to get moist. So there's going to be condensation. After the rising, it's going to expand, get colder, and then it's going to condense. Before that, of course, there was no rain. It was only warm air. So when we talk about rain or precipitation, any word you could use, so there was no rain in the warm air, and here the rain was supposed to start, right? So I would say drizzle maybe when the air is mixing with the colder air, and heavy rain because now it's condensing, right? Because it's become too cold and it has to condense. Now visibility when the air is basically rising, when it's warm, now there is no rain and the air is warm, it's there, it's moving towards the cold air, so visibility would be good. Now when it's mixing, now there's so much of air mixing, rising, and when the front is basically being formed is actually when the warm air starts to rise. So in the rising air, it was an instability condition, if anybody has seen the stability video. So here it becomes very poor, also because these clouds are formed because it leads to formation of fog. So then the visibility again goes down. Here a lot of rain is happening. So if you know that when the lot of rain is happening, heavy rain, it's not really good. But as compared to fog, it's still better. So I would say not very poor. I can say just good, but I won't compare this and this together. This is obviously better. Here there is precipitation, so it has gone down. The visibility has gone down. Poor visibility definitely. I'll say poor only, poor visibility. And here it's only very poor. Here it's, okay, I'll put poor here and very poor here and only poor visibility here. So I was correct only. Yeah. So very poor here and poor here. Why? Because there is fog here and there is rain here. So there's a difference in the visibility. Great. So this was all about the warm front. Now we'll talk about the cold front. So in the cold front, the cold air is overtaking the warmer air that's ahead. So we have the warm air over here, like I'll show you. So this is the warm air, okay. Here it's already showing that it's rising, but the warm air is ahead. Okay, let me make it here. So this is maybe the warm air, and there is a cold air that's approaching the warm air. It was previously the warm air was approaching the cold air, but now the cold air is approaching the warm air, okay. And the cold air is over here, like I said. Now what we know is that the cold air is heavy. So what happens is that the cold air undercuts the warm air and forces the warm air to rise. So what really happens is, if you see the diagram here, okay, and let me make it yellow in color and a little more, yeah. So when the cold air is coming in this direction, if there was warm air, it was forcing the warm air to go in the upper direction. Because warm air is lighter, so the warm air starts to rise and it is being forced to rise. And when a warm air is being forced to rise, in that case you know that the cumulonimbus or the vertical development clouds are formed. Okay, so if this is a ground, so the warm air is basically rising, and suddenly the cold air starts coming and it undercuts the warm air because it's heavy. So the warm air starts rising because of the cold air is pushing here. So it's being forced to rise. So very important, massive clouds, vertical development is formed. So what is very important here is that massive vertical development clouds are formed. And what are these clouds? They are CB clouds that are very dangerous. Cloud development because of the frontal lifting. We talked about frontal lifting in the chapter of thunderstorms. Alright, so here we will observe that these clouds are formed because it is the warm air is being forced to rise. So the slope of this cold front is faster. It is 1:50, the slope. So the pointer 1 would be that cold air is approaching the warm air. Cold air is approaching warm air. This is what a cold front is. Then of course this leads to the development of massive vertical development of clouds. So these are mostly cumulonimbus cloud, the vertical clouds that are formed, and also the slope is 1:50. That is, for every 50 nautical miles it's going ahead horizontally. For every 50 nautical miles it is going ahead horizontally. It is rising by 1 nautical mile. So this slope is basically steeper as compared to 1 is to the other slope that we were talking about in the warm front, which was, where is, okay, I deleted it, which was 150, right? So that is why it is steeper. Now next is we're going to again talk about the properties. We're going to talk about behind, at and ahead of this front. So what really a front is basically a boundary. So I will also talk about this, representation. So if you see, this is how a front is represented on a surface chart. I have a picture which I'll talk about in the end, how they are basically represented. So let's talk about all the properties now. So we already know what is behind, what is at, what is ahead. So we're going to talk about the cold front here now. So in this you would see that there was warm front ahead. So obviously the temperature is going to be warm ahead of the front. At the front the temperature is going to keep falling because the cold air is approaching. Okay, and it was obviously cold because the cold air was approaching the warm air mass, right? Now the pressure, since the warm air is again rising, so it will fall, so it will be low pressure ahead, and the pressure would start to fall, basically it become minimum when it is approaching, the cold air is approaching, and cold air, obviously the temperature is high, so it is high, right? So it keeps rising here. So it's not rising, I would say, but the pressure is as compared relatively higher because obviously the cold air is there. So the pressure is low after, because the warm air is rising. Now when we talk about the winds, again you would see that the winds are veering, right? And here of course the winds are again backing, and here again you would see, okay, now here at the at the front we would say squalls are there. I'll tell you what squalls are, and we would say that it is gusty. Why? Because we have what kind of clouds being formed? Cumulonimbus clouds. So at the front the winds are bad because of the CB clouds, the vertical developed clouds. That is one of the reasons. So here it is veering, here it is backing, but at the particular front it is gusty. Now the clouds, obviously here we would say that they were different, like isolated clouds. In the cold air normally there are isolated cumulus clouds, but when they are meeting the warm air and the warm air is being forced, right, so CB clouds are formed. Okay, CB clouds are formed, and after the front now there are a lot of gusty weather already. So there CB is already there. There are cirrus clouds, then there are cumulostratus clouds, then there's altocumulus clouds. So all these clouds are formed after the front. Then we talk about the precipitation, that is rain. So rain, when you have cold air, obviously there was already rain because heavy rain was there. In the cold air the temperature is already so low, it has condensed, so it's obviously showering. But when we talk about going ahead with the cold, now this air is taking that rain ahead also, and there is formation of CB clouds, so again very heavy rain. And here also there are CB clouds, so again heavy rain. So the rain is always there. Now since the rain is always there, the visibility is going to be poor throughout. So here is poor, and after the front has moved, then it will clear. So first it's poor when the front is approaching, the cold air is there, the rain is happening. Now the cold air is meeting the warm air, the front is moving in the right direction. That is why we talk about the slope. So there clouds are being formed. So here it will be poor, and then it will start to clear. Here at the front will always be poor because there are CB clouds, and ahead also will be always poor because there are CB clouds. So take a screenshot of this. This is all about cold front. Now, so a stationary front is one of the simplest front. Here basically no air mass is approaching the other. So there is a cold air mass. So here there is a cold air mass that's there. Then there is a warmer air mass that's there. But they are basically are opposite and parallel to each other. So this cold air mass is maybe moving in this direction and the warm air mass is moving in this direction. So there is a front being formed because front is the boundary between the two air masses. So this could be, I'll mark it with red. So this could be a stationary front where there is warm here and there is cold. These diagrams I'll show you what it really means. It's already here. If you see here is, this is how it's represented on the charts. So the warm air front and the cold air front are there opposite and parallel to each other. They are not moving towards each other. This is known as a stationary front. I have a picture. I'll just show you before we go ahead here. So this is how warm front is represented. This is how cold front is represented. This is how stationary front is represented. So when the circles are in this direction, that means the movement of the front is in this direction. When this, if the circles are like this, red in color and this, so it will move in this direction. So this will be in red in color obviously, and it'll move in this direction. So in the direction the circles are, the front is moving. This is of course cold front, so it's obviously moving in this direction. Occluded front we are going to talk about. So this is how it's represented, and this is the stationary front where there are two air masses parallel and opposite to each other, so they're not moving towards each other. So this is how it's represented. Now we're talking about the occluded front. So in occluded front, it's a very simple front. We will talk about occluded front more during our winter season in the next video. So basically what is happening is that a cold air is approaching a cold air. What it really means is that this air is colder. This is just cold. So when a more colder air is approaching a cold air, that is what the occlusion is, and this is what an occluded front is all about. And the warm air is obviously here in between, because it's obviously whenever obviously there is going to be warm air somewhere, right? But it must have already risen. Warm air is lighter, so it's risen. So when a colder air approaches a cold air is what is a occluded front. So why it is in the winter season? Because in winter India is already cold, and then there is even colder air that approaches the India. So basically a colder air approaching an already cold air in India, because the temperatures have already gone down. So that is when the occluded front is formed, and that is when the winter season we are going to talk about it. So this is all about occluded front. The last part is I'm going to talk about three definitions. Okay, just two definitions, sorry, that might come in your exams, and that is, one is Frontogenesis, and then there is another term that is Frontolysis. What it really means is frontogenesis is the formation or strengthening of a front. Okay, so how do I learn? Because fronto and fronto is the same. So how do I learn? I talk about G. G means growth. Right? This is my way of learning it. So basically the front is being strengthened. So these could be your, options of your exam. So the formation, or you could say strengthening of a front. This is frontogenesis. When I say frontolysis, that is the opposite obviously. So this is the dissipation. It's not forming, it's dissipating now. So dissipation, or you could say a weakening of a front. So these two definitions are also important. One last thing that I wanted to talk about is when I was saying that, the in the northern hemisphere, if I'm talking about, when I said that the air was veering, behind, at and ahead, we were talking about. So when I was saying that, so high pressure air moves in the clockwise direction. So this was obviously high pressure and it was veering. So one of the reasons of high pressure was this, and since it was veering and it was high pressure, so it was weak. Low pressure has a strengthening of air because of the isobars being so close together. So when it was ahead, when we're talking about the ahead or the before part, so it was veering. Veering was here, and the winds were weak because in high pressure winds are weak as compared to the low pressure area where it was going in the anti-clockwise direction. So it was backing and it was strengthening. Okay. So this is very important. So I'll just go back to these diagrams. So when I said veering, so in the veering part, wind was weak. Okay, this is very important. And when it was backing, it was low pressure area. Yeah, low pressure was there. So it was strengthening. Okay, similarly, if I come to the this front, again it was high pressure here, so it was wearing. So here, yeah, so here the wind was veering, so it was weak because of the high pressure, and here it was strong. And why is it? I just explained to you that how north in the northern hemisphere the high pressure is in the clockwise and anti-clockwise is strengthening of the winds. Why? Because in the anti-clockwise the isobars are closely related, so there's a lot of steep pressure gradient. The pressure is changing very fast. So this is the one of the reasons, and we're done with the front chapter. So these are the questions from IC Joshi. Just take a screenshot, attempt these questions at home. So they are very important, and if you are done with these questions correctly, you are done for the front chapter. It's a little tricky, so don't worry. Only these questions should be good to go, and we've already learned a lot on the front. Thank you for watching my video. I hope you learned something today. Also, please do not forget to subscribe to my channel. It really motivates me to create more content, more videos for you all.